Hey everyone, today we're doing 12.4 similarity in right triangles, and specifically we're going to talk about right triangles and the altitude of a right triangle. So we're just going to jump right into it here with the geometric means theorem. And the geometric means theorem is the theorems, or it's a series of theorems here, but they relate to the relationships of the sides when you have a right triangle um, that is divided here with its altitude. The two of the altitudes of a right triangle are just the legs. The third altitude is the one that is perpendicular to the hypotenuse. So think of this big triangle here. And the line that is perpendicular to the hypotenuse that goes through this vertex is line H. And it divides it into two more triangles. So we have a total of three triangles, right? We have AXH, we have triangle HYB, and then finally the big one is triangle ABC. So those are our three triangles here. Note we're going to just refer to these sides with the lowercase side name letter names. So the first one is that the length of the altitude of the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So that tells us that H here is equal to the geometric mean of X and Y. So this is H, and then this is X, this is Y. And this is kind of the easy one to remember because geometric means fall between the two extremes, right? It's a mean. And X and Y are these two lengths here on the big triangle. So H is the geometric mean, right? The geometric average of X and Y. And here's our calculation. The other two are a little harder to remember, and they involve C. It says the length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. So what that means is that A here, the length of leg A, is equal to the geometric mean of X and C. So here's X, here's C. And we average these two, and that gives us, not regular average, but we do a geometric average of those, and that gives us length A. Similarly, if we want B here, we take the geometric mean of Y and C. So these three things, it decided for some reason, maybe just to make it more intuitive, it put this equation up here. We're not going to use this top equation for any of these. We just want to focus on these bottom equations. So circle these three in your book. These are the ones you want to use. And we'll do an example. Okay, so this one here, we have this same setup, right? We have a right triangle with the altitude. So we know all three triangles are similar. So therefore, we can go, we know that, this is a good proof of the geometric means too. We know that all three are similar, right? And so I have these similar triangles. Here's one of the triangles. So that's one of the triangles. The other similar triangle is this triangle. So I know these two triangles are similar. I'm going to mark that with a 90-degree angle here. So these angles correspond, and then it should be pretty obvious that this angle here corresponds to this angle here, and then this angle here, put double mark for congruent, corresponds to this angle here. Okay, and then I know some of the values, right? I know that this is X. I know this is 10. I know this one is 2. I know this one has X. So now once I have my head kind of around that space, I can realize that, oh wait, this is just the proportion stuff we've been doing before, right? If they're similar, that means that they're proportional. I can say that X over 2 equals 10 over X. Or I could say that 2 over X equals X over 10, or I could say 10 over X equals X over 2, something like that, right? The one the book uses is 2 over X equals X over 10. right? This side here over its corresponding side is equal to this side here over its corresponding side. The trick is there's two x's here. And then when we cross multiply, that gives us x squared equals 2 times 10. Or we can take the square root and say that x is equal to the geometric mean of 10 and 2. So we did it here without using the cool theorem, but if we use the cool theorem, we're using this one, h here. H is equal to the square root of x and y. So h is this altitude. It's the square root of x and y. Similarly, we can say that x here is equal to the square root of 10 and 2. And so we can just jump straight to that and just say x equals square root of 20, which is 2 square root 5. 2 square root 5. So we can just jump straight down to that. We don't have to go through all the rigmarole. Okay. So let's try this one. What is x? We figured out x, so we know x. The cool thing is, if we know x as the, 2 square root 5? So 2 square root 5. We could figure out y using the Pythagorean theorem. We could also figure out z using the Pythagorean theorem. But let's show it without using the Pythagorean theorem. So in this case, we have 10 over y. And what do we want to set this equal to? We want to set this equal to some triangle where we know the values. What's the other triangle that uses y? Well, it's going to be the big one here. So here are my two triangles this time. I have that triangle there. And then the other one that uses y is this one. Okay. I know that these two triangles are similar. That side corresponds with this side. This angle here corresponds with this angle here, and this angle here corresponds with this angle here. Again, I know that this one is y. I know that this one is y. I know that this one here is, this one here is 10. And so this side here is z. Oh, this one's 12. Yep. Okay, so we don't need to worry about the short side here of these triangles. We can just say that this long leg, 10 over this long leg y, is equal to this hypotenuse y over this hypotenuse 12. So we can say y over 12. Cool, and then at this point, it just becomes algebra again. We can crank through this, blah, 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 blah. Finally, we get down to y squared equals 120. And this makes sense using our theorem here. What we're doing here this time is we're using either, think of it as this one. A is equal to the geometric mean of x and c. So A, one of these legs, is equal to the geometric mean of this entire hypotenuse and this little section of the hypotenuse here. So we can think of this as this thing is equal to this entire length, which is 12, and the geometric mean of 12, and this section here, which is 10. So 12 and 10 is 120. What's the geometric mean, or what's the square root of 120? We can simplify that out, and we get 2 square root 30. All right, see if you can find x in this one. Brand new problem. Pause right here. Yep. Okay, again, I highly recommend we jump straight to this. We can use our formula here. this altitude is equal to the geometric mean of these two parts of the hypotenuse. So therefore we can just say x is equal to the geometric mean of 5 and 7, which it doesn't reduce, so it's the square root of 35. That's as close as we can get. Okay, that's it. That's all I got.